right, we're going to continue talking about exponent properties. So first off, what I want you to do is you're going to get your calculator and you're going to enter each one of these in, and then you're going to write your answer. Now you might get a decimal. I want you to write it as a fraction, and we're going to, or especially for some of these, so you don't do any decimals, do only fractions, and you're going to start to see a pattern happening. All right, so what we're going to do is, if you were to look here, you'll get 8. And then 2 to the second power is 4. 2 to the first power is 2. Now you're going to start noticing some interesting things happening. If you're to have 2 to the 0 power, that's actually going to change to 1. Oops, I'm going to make that a little bit thicker. And then now, if you notice, we have negative exponents. So you're going to start seeing some things happening with the negative exponents. Now you might get 0.5, but remember we said to write that as a fraction, and you're going to get 1/2. And if you were to do 2 to the negative second, you're going to get 0.25. Which as a fraction is 1/4. And then you're going to go ahead and you're going to get 2 to the negative third power. So when you do 2 to the negative third power, you're going to get 1/8. And if you notice, there's a pattern here. When it's 2 to the third, 2 to the negative third is 1/8. So all we did was we basically did a little flipperoo there, and then that gave us 1/8. When we had 2 squared, we got 4. 2 to the negative second, we had 1/4. 2 to the first power is 2. 2 to the negative first power is 1/2. So really, all we're doing is doing the reciprocal, and that's going to give us those. Now, this is important because this is saying you have 0 groups of 2, but you do have a number there that is happening. So basically every time we're dividing by 2, and we're just continuing the pattern. All right, so now we're going to get into reviewing negative exponents. So just like we said here, is what we're doing is we're taking the reciprocal, and the negative exponents are what move. So you move the negatives. If it's a positive exponent, you keep it. So what I think here is I take whatever is here and I'm going to move it to the denominator. When you move it to the denominator, you're changing the sign of the exponent only. So let's look here. So imagine this is over 1. So I'm taking all this and I'm moving it to the denominator. And when I move it to the denominator, instead of a -4, we now just have a +4. And remember, you're flipping it, so you need your space, your placeholder here. All right, so same thing here. If I have 4 to the negative y, this is your negative exponent. We're going to flip it to the denominator, and when you do that, it's a +y. And don't forget, it's over 1 because you're moving it. Now, let's look at this one. For this one, again, remember, if there is no exponent, write an exponent of 1 in. So this is going to stay where it's at. But this is a negative exponent, so that one we're moving. So again, 5 to the +1 stays here. And we moved only the negative exponent to the denominator. Now you can have more than one negative exponent. So again, the exponent for 7 is positive, so we're keeping that in the numerator. X squared is negative, so we're moving it to the denominator, or negative x squared to make it positive x squared. And then y to the negative third, we're moving it to the denominator, and we're changing the sign of the exponent only. All right, I want you to go ahead and try that one. Now, we're going to keep going, but we got a little change to it. So, when you think of this, again, remember, if there is no exponent, you're going to write a 1 there. And then you're going to take the power rule, and you're going to make this -1. And then we're going to take the power rule, and we're multiplying it here, and you're going to get a negative 1. So now both of these are to the negative first power, so now we can start moving them. So if it's in the numerator, move it to the denominator. If it's in the denominator, move it up to the numerator. So now we have positive 1 for your exponent since we flipped both of them, which is 4/3. So remember, change the sign of the exponent only. All right, now here, these are all in the denominator. So 1 is positive. We're going to keep 4 in the denominator. But since this is negative, we're going to move it up to make it positive 2. And since this is a negative exponent, we're moving that up to make it a positive 3. And then you can write the 1 here, or you can just, oops, what did I do? There it goes. So again, you can leave the 1 there, but it's understood the 1's there, we usually don't write it in. All right, this one looks a little wild and crazy. So first off, what we're going to do is this is the power rule. So we're going to do the power rule. And remember, if there's no exponent written, write an exponent in. And now we're going to multiply. And remember, negative 3 times negative 2 is positive 6. And then negative 3 times 1 is negative 3. So now that we've got 2 to the negative third, x to the 6th, and y to the negative third, this x to the 6th stays in the numerator. But 2 to the negative third is going to go down to make it 2 to the positive third. And y to the negative third, we're moving to the denominator, which makes it y to the positive third. And then, last part, we're going to simplify that to 8. All right, now this one's definitely multi-step. So first what we want to do is I added any 1s, just so that way we won't forget. So we're technically multiplying everything, even though there's a parenthesis here, we're still multiplying. So what we can do is we can get like bases, and we can add for 2. So I've got an x here and an x here. Well, notice I've got a 3 and a negative 1. So 3 plus negative 1 equals 2. So that's what we got here. And then here I've got a negative 3 and a positive 3. So a negative 3 plus 3 gives us 0. So that's going to be an exponent of 0. And remember, anything to the 0 power equals 1. So this one, we can actually simplify and cancel that out. And we're only left with 2 squared, which is 4, and then bring the x squared down. So this is our final answer. All right, I want you to try this one. Remember, put an exponent in there and then go ahead and combine those or simplify those. All right, so now let's look here. Let's get started. Now, if you have a fraction, simplify the fraction, or if you have a number in top and numerator denominator, simplify just like a regular fraction. We can't simplify 2/3, so we leave it as is. And then now we're going to start combining. So if I were to have 4x's here and 2x's here, you subtract. So it'd be 4, oops, minus 2, which you have more in the numerator, so it stays there. And now that's negative, I'm moving. That's negative, I'm moving. So for my y's, I now have y to the positive third and y to the positive fourth. And then here I have a negative, so I'm moving that down to here. So now let's start combining. So in this case, I should have 1 y left over because we're subtracting, and then we move the, wherever there's more, that's where your leftovers are going to go. And then here, since they're both in the denominator together, you're going to, since you're multiplying the same base, you're going to add the exponents to give you 7. So this is your final answer. All right, I want you to go ahead and try that one. And then, oops, sorry. And then, as we said before, with 0 exponents, anything to the 0 power is 1. Very important. So let's get started here. This one's super easy. It's to the 0 power. It equals 1. Now, notice 0 is outside. So you're distributing, or you're multiplying, excuse me. So you get 7 to the 0 power, x to the 0 power. Well, this is 1 times 1, which gives you 1. All right, so remember, just because you see a 0 doesn't mean everything's 1. You have to look at the exponent. So in this case, this exponent is 1. So we have 12. This 0 only goes with x, which makes us 1. And remember, you're multiplying everything. And then y goes with 3. Now we can put it all together, which is 12y to the third. All right. Now remember, we talked about if we have numbers in the numerator and denominator, we're going to write those as simplified fractions, which simplifies to 3/5. Now, here I've got 2, here I've got 0, but I've got bases of x, so I can combine those. So remember, 2 minus 0, this is actually going to give you 1. So we're left with x squared here. And then here's a negative exponent, so we're going to move it to the bottom, and we get y to the first power. So when you finish writing it, you're going to get 3x squared over 5. Oops, why did I write y squared? So 5y. So when you're doing this, just be careful so you don't make silly mistakes like I just did there. All right, now this one, go ahead and try this one. What I did is I did write a 1 in, and then this 0 goes with v. All right, now let's go ahead. This one looks wild and crazy, so let's try this one. So what I like to do first is I like to move the negatives and combine anything right away if I can. So first off, I'm noticing this is a 1. I'm noticing this is a 1. So these, I've already simplified and I've canceled those out. So now let's start to move our negatives. So I've got a negative exponent here. I've got a negative exponent here. This is a negative exponent down here, so I'm moving that up. And then now we can start to combine like bases. So since we're multiplying, we can add the exponent to give you 7. Remember, this exponent's 3, exponent's 1, so we just leave that as 3. And then that exponent's 1, and then this exponent's 1. So this would be your simplified answer. All right, quotient powers. Now, we already have kind of done this before, but again, we are reviewing our properties. But this is the quotient property. So if you are dividing the same base, you subtract the exponents, and you go numerator minus denominator. All right, and then power of a quotient property is just basically what we've kind of done before, is you're just distributing to the numerator and denominator. All right, so a couple different ways to think about this. One, you can expand it out. So 4 to the 7th power, you're going to write 4 7 times. And then here, you're going to write 4 4 times. So what you can do is whenever numerator denominator is the same, you simplify it to equal 1. So that can simplify, that simplifies, that simplifies, that simplifies. And what we're left with is 4 to the 3rd power. And notice we have more in the numerator, so that's where your leftovers are going to go. So that's one way to do it. Or what we can do is the quotient property, where you write your base and you take your numerator minus denominator. And 7 minus 4 is 3. So either way works, and then you can continue to simplify that by multiplying it all the way out. All right, now here we have the same base of -3, so I can go 6 minus 2. And when you do that, 6 minus 2 is 4. which again, you can continue to simplify. Just remember that negative's attached to the 3, which would be 81. All right, so for this one, we're going to combine the like bases in the numerator first by adding the exponents to get 8, and then we're going to bring this over. Now that we've simplified the top, now we can look at the denominator too. So now we can go 8 minus 4, keep the base the same, and 8 minus 4 is 4. If you put that into the calculator, you'd get either of these, 1,296. All right, now before, we always seem to have the leftovers or the bigger number on top. It's not always going to be like that. So again, if we expand it out, 1, 2, 3, 4, and then here I've got 9 times. All right, so remember, numerator and denominator are the same. It equals 1. That's 1, 1, 1. And I'm left with 5 3s in the denominator, which makes sense because you have a bigger number, so it makes sense that you have more in the denominator. Now remember, you technically have 1 in the numerator, so that's why we have a 1 here. All right, that's one way to solve it. Or we can go 4 minus 9, and we're going to get -5. Now once we get a -5, we flip it, so it's in the denominator either way. So either way works, whatever works for your brain. I like to just think 9 minus 4, and I have the leftovers in the denominator. And then I can simplify to that. All right, I want you to go ahead and try that one. And then I'm going to do this one since it's a multi-step. So first off, let's just look here and simplify. Well, we can simplify our x's, and we've got 3 minus 1. And so in that case, oh, that's one way to do it. What did I actually do? Oh, look here. Oh, I did this all first. So I did this way first, and then I did this first. So I multiplied all of it first. Then I subtracted. All right, now notice I've got numbers here. You can just multiply and move all those together. So I've got 36 over 4, which remember, that would simplify to 9 over 1. And then don't forget, you subtract. So 5 minus 1 is 4. And 3 minus 3 is 0. So anything to the 0 power is 1. So your final answer should just be 9x to the 4th. All right, I want you to go ahead and try this one. Watch that negative. And I want you to try this one. Watch those negatives. And let's do this, multi-steps. So again, if there's no 1 written, write the 1 in. Distribute or multiply the 3. So I'm going to get 3 to the 3rd power, b to the 12th power. And then here I have a negative exponent, so I'm going to move that up to give you h to the 9th. So now that I've got this, now we can start to simplify with our quotient. So I've got 3 3s here, I've got 1 3 here. So the difference is 2, so you're subtracting. And then I've got 12 b's here and 8 b's here, so you're subtracting, which gives you 4. And there's more left over in the numerator, so that makes sense. And then h to the 9th is over there. So remember, there's nothing left in the denominator, so we don't have to write that down. And then all we did was just simplify 3 squared, and that's your final answer. All right. So now, let's go ahead, let's try this one. So there's different ways to do this. What I would do first is I would actually distribute this first, or multiply this first, sorry, I said distribute. And you're going to get 3 to the -3rd, p to the 3rd, x to the 15th. And remember, that's a positive 15th. Watch your signs, because 2 negatives make a positive. All right, now I've got a negative exponent. So I'm going to move that up to the top. And when I move it up to the top, you're going to get 3 to the positive 3rd, which gives you 27. And then now, 12 times 27 is 324. And I've got p and p to the 3rd, x to the 15th left over. And that's it. All right, now this one is kind of a weird way to think about it, and there are different ways to think about it. So I showed you kind of a longer way, but some of it just kind of, you look at it and you think, oh yeah, what does, as long as you get the base simplified, you just figure out what you need to do to get the variable. All right, so I really don't even need to worry about any of the numbers, right? So we can kind of just ignore those. But I'm going to look at my x's first. So here, this would be a minus 5, since we're dividing. And then here, I don't have any x's up here. So this is the same as saying x to the 0 power. So I could go 0 minus 2, which is negative 2. So now your exponents are the same. We can ignore the base and just get a minus 5 equals negative 2. Add 5 to both sides. So we know a equals 3. Now you could also expand all of this out and just figure out what you need to make the other side equal. But that's one way to do it. So for b's, now I'm going to go 4 minus b. And then here, we don't have any y's. So it's really 2 minus 0. And then now that our bases are the same, we can just look here and do 4 minus b equals 2. So we're going to subtract 4. And we'd get negative 2, but since it's a negative b, we make it a positive 2. So we know b equals 2. Or 4 minus what equals 2. So it'd be positive 2. All right. So that's one way to think about it. You could also list it all out like what I did here. So whichever way works for you. And in this case, we don't even really need the numbers to help us. We can look at the x's. But what I would do is here I've got 2 x's. Here I've got 3 x's. And then I've got 1 x down here. But I don't know how many that is. So I just put a little question mark. And then I've got 1x here. Well, I know those simplify. So I'm left with 4. So we can go 4 minus a equals 1. And a equals 3. And then for your y's, you can go 3 here, 3 here. And then I've also got 2 here. And I know I need some y's up here, but I'm not sure how many yet. But I do have 5 y's here. So we know that it would be b minus 2 equals 5. So b would equal 7 because you add 2 to both sides. So different ways to think about it, whichever way works for you. But that is more exponent properties.